So perfect. Thank you. And hello, everybody. Welcome to the 2023 NIA Annual Symposium. Just a quick run through of the agenda. My name is Sean Kelly. I'm the Interim Director General of the NIA, and I'll be chairing today's meeting. Joining us, we start with the Chair of the NIA Board and CEO of Cerion Nanomaterials Limited, Landon Mertz, who will be talking to us about the current state of the global nano industry. This is then followed, we have two panel sessions, the first being chaired by Blanca, who's our Director of Regulatory Affairs, and she'll be looking with the panel participants at creating the right regulatory environment for nanomaterial innovation in the EU and US. And the second one will be chaired by myself, and we'll be looking at global leadership in next generation materials innovation. We aim to close in around about 2 hours' time. And the time here is shown in Central European time, but obviously in your own local time zone, you'll be able to work out 2 hours from now. So we hope to be able to close on time, and hopefully everyone's going to have a very good meeting. And on that, I'll hand directly over to Landon and ask him to share his screen and start his presentation. Thank you.
Okay, thank you, Sean. Let me work on sharing my screen here. So this should do the trick. Okay, and so first of all, Sean, thank you very much, and really to the broader NIA team for pulling this symposium together today. And I know we have people literally joining us from around the world. And so I want to thank you all for taking a little bit of time out of your day so that we can have this very important conversation. This is somewhat of a unique event in that it's the first time that we've really opened the annual symposium to non-members. And it's for a special reason, which I'll be sharing later on in this presentation. But very quickly about myself, I have been in the nanomaterials industry now for about 14 years, running Cerion Nanomaterials, which is one of the largest in the United States for manufacturing, designing, and scaling inorganic nanoparticles. And that's specifically metal oxide, and ceramics. And I thought, because we may have some members of the community today that perhaps are not as familiar with nanomaterials, I'm going to do a very quick primer. And this is a primer that I'll be the first to say will have a lot of generalizations. So I hope my colleagues in the industry will give me grace in glossing over some of the details. But for those that aren't familiar with the scale of nanomaterials, we have our commonly known items. Something like a period on a paper is about 1 million nanometers. A sheet of paper, its thickness, 100,000 nanometers. Engineered nanomaterials, which is where our industry works, tends to have at least one dimension that is less than 100 nanometers. In a lot of cases, truthfully, what you'll see is that many materials have dimensions under 30 nanometers. And that's for a very specific reason, mainly that the smaller you go in size, the harder you're able to drive a reaction and express certain behavior out of the particle. But fundamentally, what are we trying to do? When we get down to very small sizes, we're trying to leverage the bizarre behaviors that a material might exhibit. And then we're trying to take that behavior and then express it into some kind of new product. And there's, broadly speaking, two mechanisms of action. The first is, as you decrease size of a particle, you're increasing the number of atoms that are on the surface of a particle to do work. And then the second is you're trying to leverage the electronic properties of the particle itself to do work. And so what we're really trying to do with the nanomaterial is play with and fine-tune the attributes of the material itself, whether that be the specific material, its composition, its particle size. And what we're trying to do is influence certain behaviors, mechanical, magnetic, thermal, or whatnot, and then we're leveraging that into a product. So I thought I would start this conversation by really trying to focus on The way that I think of the world, I know certainly the NIA feels the same way. And that is really talking about general purpose technologies as a broad class of innovation. So when we think about innovation, there's kind of four modes, if you will. You have your incremental innovation. I don't think I need to describe that to anybody. You have your architectural innovation. So you're taking existing technologies and you're trying to apply it to a new market. And then your disruptive, your new technologies, which are put into existing industries. And then, of course, the most radical of all, which is an absolutely new technology that opens new markets. So, but irrespective, you could think of innovation's impact to GDP as really narrow and oftentimes sector specific. So, for example, a self-driving car is very sector specific innovation. And then we get to general purpose technologies. And this is a really fascinating class of technology of which nanomaterials are a part. And a couple defining features that make them set apart from other modes of innovation. First, they're not common. If you look back over the last 10,000 years, you're going to find that maybe 2 to 3 general purpose technologies came about every 1,000 years. So they're a very, very, very scarce resource. You'll also find that the frequency, or really the emergence of a general purpose technology, it accelerates over time. The more general purpose technologies that are in existence tend to develop and diffuse new general purpose technologies into the economy. And then probably my most favorite is they have no competition. If you think of, for example, the telephone system or computers, they become pervasive and they work their way into every corner of society because they have no rival. But probably the most important from the perspective of both companies and government is it gives you an opportunity to dramatically raise productivity and ultimately drive increased competition so that you win on the global commercial stage. And the most defining feature of a general purpose technology is that it is broad. It is not sector specific. There's a great debate out in some areas of the community on whether a general purpose technology is an invention or really a discovery. But at the end of the day, when I think about general purpose technologies, this is really what innovations get built upon because they are platform systems. So if we look back over the last millennia, but more specifically the two industrial revolutions, what we find is that the GPTs of the day were things like the steam engine, railways, electricity. And to just kind of show how general purpose technologies reorder society, going back to basically 1 AD all the way through the early 1800s, real GDP growth was somewhere on the order of less than 1% a year, which is pretty astounding. And you can see here from this chart, these two gray bars, that as these GPTs started to diffuse into the economy, GDP took off like a rocket ship, and it completely changed really the health, the welfare, and the prosperity of society writ large. But there's one defining feature. He who has first mover advantage and deploys GPTs into their economy, at the end of the day, the victor goes the spoils. And so, as everybody here knows, the West, the collective West, really embraced general purpose technologies, moved them into their economies fast. And so they took off like a rocket ship from a GDP perspective relative to the rest of the world. And so what that really says is in the here and now, nations and companies within those nations really need to be competing to take that first mover advantage. This is somewhat of an interesting slide, but I think there's a few takeaways here, which is that GPTs diffuse rather quickly into an economy. I looked at electrification for a study about GPTs, and you can see that nothing happened until it all happened at once. And so you can see that, steam was the primary mode of power of the day and very rapidly tailed off as electricity came in. And you can also see on the right-hand chart, over those 35 years, pretty much every single industry adopted electricity because, again, electricity had no competitive rival. So the general purpose technologies of today, there are 7 of them. Most of them people know quite well, especially if you followed some of the things happening with OpenAI. You have artificial intelligence, obviously semiconductors, communications, quantum, and then you have nanomaterials. And interestingly enough, nanomaterials touch many of these other GPTs and actually enable them. And so this would make sense, obviously, because materials are foundational technologies. You can't build your future tech if you have nothing to build them with. And so I'm sure you are all familiar with kind of a application map. This one is particular to AI. But you can see how the use cases for AI literally touch almost every corner of society, some more materially important than others. And I tend to think of AI as more of today at least, the enabler for soft tech, whereas nanomaterials themselves really are the enablers for hard tech. And again, they will touch every corner of society. They will generate wealth. They'll generate safety and prosperity for nations. So I think the one thing that you do have to ask yourself is, while we took ownership and deployed GPTs into our economy in the West in the 1900s, what if another nation had taken those GPTs and deployed them first? How would that have reordered our economic prosperity, our defense posture, our foreign policy posture? It's a very interesting question that, if you think about that for just a little bit of time, you realize that you wouldn't like the results that ultimately you see. So today we have an industry landscape for our community, and there are a number of risks for the industry, whether they're real or perceived, and they really run the gamut. I believe there are about 3 slides here, but of course we have this ongoing debate in the public about societal concerns around nanomaterials. I think that's a very important thing for us to address. We have some shifts in industrial policy, which I'll speak to in a moment. Of course, health and safety concerns, environmental impacts, regulatory challenges for the industry. And then, of course, within the industry, because it is still quite nascent, market acceptance and awareness still is a challenge. We do have competition from alternative materials. And then we have a whole series of kind of economic issues that we have to work through related to production costs. Workforce, at least in the West, has continued to be a challenge. And then, of course, intellectual property is, especially globally, is a very complicated field, which many companies struggle with. But I think the headline takeaway here is, over the last 15 years since the NIA was founded, we focused as an association really on a regulatory product, if you will. And that absolutely has very, very high relevancy today. But we do have new threats and new risks as we've matured as an industry. And the NIA really is going to focus its core activities on these threats and risks on a go-forward basis, which I'll be touching on in a little bit. But first, probably one of the largest threats that the industry in the West, at least, has up against it is industrial policy. Now, first, I want to say I harbor no ill will on the industrial policy of nations. Every nation has the right and the ability to engage industrial policy that they believe meets the needs of their country. Now, in the case of China specifically, they have, and most people aren't aware of this, they have a program called the National New Materials Industrial Development Policy. It is specifically focused on frontier materials, of which nanomaterials is a large focus. And their mode or their policy approach has been very, very significant. This is not a small effort. This is a whole of government effort. And while I don't have time to go through all of these various points, we have things like matching investments, writing off or helping defray losses for the venture capital community that takes very, very early stage risk, subsidizing interest rates on loans, facilities, very substantial discounts for the first 3 years of life of a company, all kinds of cost of living and talent subsidies, and even bonus tax deductions. And they've also made very considerable infrastructure investments. Now, in China, there are about 4 or 5 technology parks that are specifically focused on nano. But probably the largest and the most well-known is going to be Nanopolis. And the interesting thing here is they're focused on 4 key areas: nanomaterials, nanomanufacturing, nano for health, which is a recent addition, and then, of course, who couldn't add semiconductors into that? But really, the scale is, I think, the thing that most people aren't aware of and that is quite impressive. So this Nanopolis was at one point about 5 million square feet, 500,000 square meters of office, lab, and pilot facilities. They've just announced that they're expanding to 7.5 million square feet, or 750,000 square meters. They engage in incubation of companies. Every single year, they add about 40 to 50, and they spend in excess of $300 million a year on those incubation activities. And within this kind of megalopolis, if you will, for the nanotechnology community, in 2020 numbers, they had about 700, 800 nanotechnology companies in the park. That's now since expanded to 1,100. And they have, I would say, roughly 30,000 people that operate within the park. So the sheer scale of industrial policy is, I think, the thing that is quite interesting. Now, when you look at the capital markets that put money into advanced materials and nanomaterials globally, it represents less than 1%. I believe it's 0.7% of all venture capital and private equity goes to materials companies. And so China has very rightfully said, okay, well, if the capital markets are not going to be here, well, then we need to step in because we view this class of materials as being strategically important to the future of the nation. And so the risk, of course, for companies in the West is it's very difficult to compete with the balance sheet of a government, as you could naturally understand. So what is our role in all this on a go-forward basis? So we recently redrafted our vision for the NIA, really with the question of where do we want to be 10 years from now? Today, we are highly focused on regulatory policy. Where do we want to go? At the end of the day, is we want to be the definitive voice for the nanotechnology industry. And we want to ensure that the public, the ultimate consumer, typically an industrial company, understands the value of nano, and that nano really is kind of recognized, respected, leveraged, integrated into the fabric of society. And the way that we see getting there is really by expanding the tent. Today, our membership largely comprises companies that are focused on regulatory policy only, but they tend to fall into 3 broad categories, which is a nanomaterial maker, a nanomaterial user, somebody who's acquiring it from a third party, and then what I would call a user maker. So they are developing a nanomaterial to solve an industrial challenge. They're creating a product. And what we're looking to do now is to really broaden the tent and bring more of the community in. And so while this list may not be complete, it kind of represents on the right-hand side of the screen some of the people that we want to bring to the table and get involved in the community on a go-forward basis. Everything from the equipment manufacturers to analytical equipment manufacturers, the capital markets, regulatory service providers, so that we can start to foster a community that is interactive, engages, and really tries to solve challenges as a whole of community approach. And then, of course, we also want to, ensure that as an association that we have many more touch points, not only with national governments, but supranational organizations. So, these are the legislatures of key countries, a focus on getting governments to support commerce and trade. Of course, a part of our continuing mandate, health, safety, and environmental. And then also nanomaterials do play a very large role now and into the future around national security and defense. And I can tell you that the community does not really engage in this area heavily. And I think we all have contributions to make here. So we do plan on having a fairly dramatic expansion of the NIA offering. Ultimately, if you would think of the NIA as both a product and a service, what we're looking to do is really expand the scope of disseminating industry news, engaging in formal industry studies and data, taking commercial and HSE policy positions and engaging with the relevant organizations there. And then to really build and enhance the community, we want to put a lot more effort into things like learning and education, career development, workforce development, and then most importantly, especially for our commercial members, is economic development. So while this isn't a complete list, I hope this shows kind of the breadth of the direction that we wish to head. And then the other thing is right now, in order for us to kind of build community and keep community engagement up, it's very much a manual process. And so after a lot of due diligence, we have gone through the mechanics of evaluating multiple software platforms. We've decided on one, which we'll be rolling out later next year, that really allows the NIA to be at work 24/7 and for the community to be engaged anytime they want on any topic they want. But I really do believe that the engine that's going to drive community engagement inside the NIA is a new committee model that we've spent a lot of time, put a lot of thought into to really build up the community and to ensure that all voices are heard. And without belaboring all of the detail within, what we anticipate doing is setting up a series of committees. First, around core member interests. So this could be economic policy, testing and standards, regulatory policy. We also want to set up committees related to kind of our product and services so that there is oversight from the members and the members can guide the direction of the association. So these would be things like learning and education and workforce. And then also, we will have a larger member base. We want to ensure that their voices are heard and that their agendas and priorities are met. And so we're also looking to set up committees that are related to, for example, higher education or the capital markets, and really try and foster the interaction between committees to achieve the goals of the entire community. We also anticipate setting up something a little bit unique, which we're calling a special purpose committee. So these would be, in my mind, time-bound, limited objective committees that align with either all member interest or some member interests. And so you can see at the bottom of this screen, something like a nanomaterials, the definition of nanomaterials. This impacts every single member from a regulatory perspective. So this is, an effort that we would create an SPC, push it out to the market. When its job is done, the SPC gets closed. Whereas more niche topics that might be very specific to a class of nanomaterial producers or, a particular application, you can have a limited time SPC to address those functional issues for that industry. And then when you're done, you close it down. But I do see, as a function of time, that this is the way to build the NIA into a significantly larger organization and to really capture that vision of being the definitive voice of the nanotechnology community. So now I'm already 3 minutes over. When is this going to happen? Well, Rome wasn't built in a day. Today, what we wanted to do was really get a preview out to not only the members that are here today, but the broader community. I can tell you from personal experience, our board and the NI team has been working on this in earnest for most of the year. There are really fantastic strategic and tactical plans that have been built, and we're going through the next stage of kind of rigorous financial evaluation on how we're going to get that done. But I would expect you're going to see more news in Q1, maybe Q2 of next year, and we certainly will be doing this in a staged rollout. So just very quickly, if you're not part of the NIA as a member, we would really encourage you to consider a few actions. The first is, at a minimum, go to the website, get on the newsletter, stay in touch, stay in tune, so that you know what's going on. If what you heard today you believe is relevant to your organization, then by all means, please join as a member now. But more importantly, spread the word. One of the things that I think we all have to do as a community is really rally behind the cause and take the time and the investment and the energy to make the NIA the definitive voice for the nanotechnology industry. And with that, I just want to say thank you. I'm sorry I'm a wee bit over, but at any time, you shouldn't hesitate to reach out. I have left my email address there along with Sean Kelly's, who's the Director General, and then, of course, the website. So thank you very much and have a good one.
Thank you ever so much for that, Landon. I would say if people have any questions, if you want to put them into the chat, we can make sure that we address them. But I'll move on straight away and introduce my colleague Blanca, who will in turn introduce the panel, and I'll hand straight over to you, Blanca.
Thank you very much, Sean, for the introduction. So I'm now going to chair the next the panel session on creating the right regulatory environment for nanomaterial innovation in the US and the EU. And for this, we have a great panel today, and thank you very much for joining us. We have Andrej Kobe, who is a policy officer at the European Commission. We have Alex Stanton, who is a team leader at the US EPA. And we have Shatkin, who is the president of Vireo Advisors. So I have you all on the screen. Great. So I will start by asking you some questions. However, please, anybody in the audience who has any question, please post them on the chat, and then we can start the discussion. So I will start now to break the ice. My first question, of course, is to Andrej Kobe on the nanomaterial definition. I'm sorry about this again. We know that the European Commission published a recommendation for a definition last year. However, this definition hasn't been taken up by regulation yet, so it's not regulatory binding. Now to question Andrej to you. First of all, can you give us some timeline on how the nano definition will be uptaken by the different main regulations like REACH, cosmetics, biocides? And the second one, if you have any idea how this new regulation will impact the industry, perhaps some dossiers will need to be changed because of the new definition. So I'll give you the floor if you can give us your insights on this. Thank you.
Okay, thanks. First, thank NIA for the invitation. I've been to a few of these symposia in the past, always very informative. And we also got some insight as we were developing our regulations at the time as well from the organization, which was very appreciated. To come to your question, first, you already put our Commission recommendation, which we basically put out in a revised form. It was actually a revision of the recommendation from 2011 last year. It's actually Commission recommendation, which is somehow binds, instructs, encourages the Commission as well as maybe the wider public to take it up in the regulatory provisions where there are some nanospecific requirements which require then that they're being triggered by something, and to have a harmonized definition certainly would facilitate regulatory implementation. That was the idea behind 2011 and behind this revised definition as well. Why do we have slightly different definitions? Maybe in the different regulatory frames, like on products or under REACH and so on, maybe a bit matter of history. We have taken up the 2011 recommendation in REACH, in biocides, medical devices, but maybe not yet in the complete range where we have nano-specific provisions. So now we have a new recommendation. It is basically the changes of it to answer the latter point, maybe changes to the previous Commission recommendation are under our account relatively minor. They are hopefully clarifying. They should facilitate implementation of trying to identify whether you are a nanomaterial or not. It's also accompanied by guidance to that extent. Then it also tries to be slightly more future-proof than the first 2011 definition, in particular on trying to be more generic with regard to identifying maybe the 1D, 2D nanomaterials, as we would say, so the platelets or the nanowires, to capture them, because previously maybe only the carbon allotropes were well covered, not all the others. Apart from that, I would say let's not overemphasize the impact of the definition per se. I think that this is it is needed in order to push some specific provisions that we have in the regulatory requirements, but the objectives principally behind the regulation stays the same for chemicals and nanomaterials throughout our regulation. It's to somehow have relevant information which allows you to properly assess your material for hazard assessment, risk assessment, as depends maybe slightly on regulation, in order to be able to safely manage the substance. So that objective is the same. We just try to ensure with some specific provisions that the relevant information is really there and that the assessment is appropriate. So putting too strong a power on the thresholds might actually somehow also slightly defeat the purpose. But to answer a question, the impact might not be big. We do expect that there might be some new dossiers, for example, under REACH once it happens. I cannot now say exactly when we will update the definition under REACH. We are certainly had prepared already an update. It will go together as the REACH, the general REACH revision is taken on, which we have been working on now, but maybe we might be working in the next commission to actually present the full revised proposal. And the others have actually also moved on, and the changes, for example, in cosmetics and in the food sector, I believe you can see in probably already next year if as proposals they move forward. I know they have effectively been finalized.
Ah, okay. For cosmetics and food, okay, they have been finalized. But
it depends, of course, whether how the proposals are being brought forward. This has been technical work, but there are formal steps to be taken in order for them to become part of the law. Until then, the existing legislation applies, of course.
Thank you, Andrej. Now I don't see any questions in the chat, so I'll move on to a question for Alex and maybe also Joanne. It's about the uptake by regulation of new approach methodologies and alternatives to animal experimentation. How will the US and also EU, if Andrej also wants to comment on this, will handle this transition? Thank you, Alex.
Yeah, so in 2016, the law for generic chemicals regulation in the US, the Toxic Substances Control Act, TSCA, was updated. And in that was a mandate to move away from animal testing wherever scientifically feasible. And so that's true for all chemicals that we're working on, not just nanomaterials specifically. So I'd say that general push to develop applicable NAMs is important to us and is something that we're working on for all types of chemicals and are interested in for all types of chemicals. I'd say, as with most scientific endeavors, it's going more slowly than we would like. But I think that's generally true for anything worthwhile. You can dream big and then it takes a little bit to actually accomplish. But wherever it is applicable and reasonable and high quality, we are doing our best to adopt NAMs and implement them into our regulatory work. I can speak for that.
Thank you. And Joanne, we'd like to have your view as well from Vireo Advisors, please.
Yes, thank you. I will say first about the definition that I think it remains a challenge because not only is each jurisdiction applying different terminology or considerations, for example, more of an emphasis in Europe on size distribution, in fact, size distribution by number, compared with the EPA, for example, tends to focus also on functionality and whether there are unique properties associated with nanomaterials. This creates a lot of confusion for industry and also some burden because there are different testing requirements and perhaps different conclusions that would be drawn in different markets. And this is also true by application category, right? So food and cosmetics are handled differently from chemicals. So I think there is still work to do in terms of harmonization and agreement about what constitutes the importance of segregating materials between 1 and 100 nanometers from other substances. On the topic of NAMs, I am a proponent of them. I've had international projects to try to advance their use, both for chemicals and also specifically for nanomaterials, where it's still not clear when you can group or not group substances. And there's been a lot of work, particularly in Europe, to advance this concept. But I think I concur with Alex that it's taking a long time. And at the moment, there is, I would say, fairly limited acceptance of the use of NAMs in terms of safety demonstration. For chemicals, except for specific endpoints like skin sensitization, for example, and any other uses as well. My firm does a lot of work in new food ingredients and food packaging ingredients, and we've been quite challenged to apply new approach methods that we would prefer to use. We think that they're more sensitive, more linked to biological activity, and concern about health, safety, and environmental behavior, but fairly far from acceptance at the moment, and also quite far from being standards. I think that's an important area that we should be working toward.
You have also mentioned how slow this is happening, meaning development of NAMs. Do you have any views on this? Is this a lack of resources? But it seems like with Europe and in the US, we are investing a lot of energy in here. What is your view? Why this is so slow? And the question goes to the whole panel. If you would like to, intervene.
Do you want to go first? I'll tag on.
Yeah.
I think it's particularly for nanomaterials, it's a dual challenge here because the methods themselves, we don't have a long historical basis for development. I mean, we do perhaps if you look at environmental endpoints, but coming to health and ensuring the new substances are safe to be used, you come into questions about a single dose model replicating what happens biologically in an organism, for example. And while the science is moving ahead, there's quite a lot of information. There isn't really a focus that I see on how to standardize that or how to create acceptance criteria for those methods.
Yeah, so on high level, we're already bad at getting properties of nanomaterials when they're just normal. And then if you're going to try to look at like anything stronger than that, biological effects or things like that, and then you're going to try to apply a NAM, you're really building the plane as you fly it. And that's going to be just hard. So even though there are a lot of resources being put to it and very impressive people doing very impressive work, it's like I said, it's very important to the US. I know that we're putting in a lot of money and time into this. It's a challenge. It's just a hard challenge. And then, of course, we're not just doing it for nanomaterials, although that's what we're talking about today. This is important to us for all kinds of categories of chemicals. And, some of those might be higher priority than others. And so, there's also a distribution of resources to, interests.
Because, sorry, Andrej, yeah, please.
Yeah, maybe I would just fully concur with what was said, especially by Alex also before. On one hand, it is a hard problem. we are all very committed and we are investing quite a lot of efforts into this, but it's a hard problem. So it moves stepwise and through the endpoints also, as was mentioned. We are also trying to make a little next step as we are, for example, revising REACH to already consider further information requirements where they can be more introduced, or introduce a general environment where they might be even more easily appreciated and applied. But generally, it still stays on the level of, on one hand, development, and we try to steer that development really towards also the ability to be of regulatory relevance as it develops. So also the later steps, for example, like the validation of studies and so on, those also need to be taken care of in order for us to be able to use them effectively, then those new methods in the regulatory system. But also said, we are trying to do that for chemicals, including nanomaterials, and for nanomaterials might be sometimes even more challenging, or sometimes it might actually work slightly better. But there's always a question of effort being applied proportionally on all the issues of priorities. So, for example, we have this big partnership for assessment of chemicals of PARC, and that's also working on the development of methods. And we need to, for example, ensure that those methods that are being developed there and so on would be those that we can actually apply across the spectrum, including for nanomaterials. Or if not, let's make sure to identify where what efforts are still missing, so we can complement those to move forward along the whole spectrum.
Thank you, Andrea. Now that you mentioned REACH, and we are talking about advanced materials or advanced nanomaterials, do you see, which regulatory framework do you see taking up this new challenge? Will it be taken up by ECHA because chemicals and REACH, or maybe sector specific? Or, do you have any views on this? It's a
not
difficult one.
The way I would like to see it is that it's all one system. We would like it to function as effectively towards the reality that is out there. There are materials being produced, from chemical substances, and there are materials being produced which are being used in articles, in products that are within a specific uses, and the final objective is that this is managed safely, either from the production side or the use side or waste side. We have other objectives from the sustainability perspective, ability to have circularity in our economy. So if we are developing new materials, will they be somehow support or hinder maybe this ability to recirculate. We might have those in addition to questions of safety as well. But in terms of the regulatory systems and advanced materials, at the moment it still might depend exactly on the context, and we would like that the system as it is able to apply effectively to an advanced material if it sees it, or if it's challenged with it. So we need to be kind of regulatorily prepared. That's at the moment how we are looking at the advanced materials, wherever it might come. We are not trying to change the system or add an add-on on advanced materials, but rather make sure that the system, wherever it is, would work smoothly also as an advanced material presents itself. And maybe that will require adaptation, maybe even some add-on at the moment. At the moment, we don't have explicit plans specifically in order to generate those additional blobs, but we certainly are working towards understanding whether there are challenges in existing system on applying on those. And that's the approach I would believe, or would say, we are also taking in the OECD, where we have also the group on advanced materials. We try also through the use cases, identification of specific use cases, actually see what we might be talking about. And we have a functional description of it, and it's in particular from the perspective of research and promoting innovation. Advanced materials as a term works very well, I believe. It's very clearly targeted, but when it comes to applying it in regulation, it's not so completely obvious. So working it from the use case perspectives, and then try to see what might not work and what would need to be improved. And then we can speak about changes. That's how I would look at it.
Thank you. And the same to Alex, since we have you here today. Alex, from the US, how do you see this regulation coming in? Or you don't
Right now, we have no mandate regarding advanced materials. Obviously, we are involved in the OECD and in this, advanced materials steering group. And we're, I'd say, aware and involved on the discussions that are happening regarding advanced materials. But in terms of integrating those into a regulatory framework, it's probably premature for us to begin addressing that. I think especially right now, as we are internationally working together to find examples of, what we're really going to focus on for advanced materials, what that looks like to us. That's our immediate next step. And we're probably not going to push that beyond until we have a better idea of what we're aiming for the moment. But yes, just really enjoying those conversations in the WPMN, and trying to, we all had such a good time in nano, and now we're all venturing forth into this, kind of unknown area, and we'll see what happens with it.
Thank you. Good that you are enjoying it. I don't know if we have any questions on the chat, Sean. I don't see the chat, so.
Yes, we have a couple of questions on the chat, Blanca. The first one is from Yatin, and they ask, from the end user perspective, nanotechnology and nanomaterials seems to be beyond easy comprehension. How is the European Commission and other regulatory bodies helping to bring simplicity to the topic?
I
don't know, Alex, if you wish to start.
We are not bringing simplicity to the topic. No, I think whenever you have, in some ways, and nanomaterials could still be considered an emerging technology. Whenever you have something that is scientifically complex and new, and as we saw in the presentation earlier, touching many areas of your life, there can be concern from an end user, and a deep desire to comprehend and know more. And from our regulatory perspective, all we can do is be as transparent as possible for what these materials are and what they are currently being used in. But in terms of making that more palatable or easy to grasp for an end user that's not really within our grasp to do. So that's what I say. We strive for transparency, though, as much as possible. Obviously, we are constrained by what information is confidential to the companies who are manufacturing these nanomaterials that might be in the hands of an end user. But for the most part, when possible, we try to be as upfront. Here are the number and types of materials within the US, what they might be included in, what those exposures might result in, and how you as an end user could, feel about that, depending on the data that you are able to digest.
If I can just say from a practical standpoint, the way that we approach that with companies is to look at the product life cycle and consider how is exposure going to occur in an end user product. How is the product going to enter the economy and the environment, and what is the potential for exposure to the nanomaterial component at that point? I mean, that's typically we're not using any nanomaterial by itself that's getting incorporated into other uses. And of course, regulators are also doing this in their own risk assessments. But in terms of being able to assess the potential for safety and environmental release, it's important to have methods available to consider the exposure potential, the overall economic impact. And to tie this back for a moment to the issue of advanced materials and even advanced manufacturing approaches, a broader consideration of tracking where these go now. And there are tools that are being used at the national level in Europe by EPA and others to understand what kinds of considerations need to be addressed, but they don't seem that far out of the realm of how regulatory considerations are made today, which is what's the overall exposure to health and to the environment.
Thank you so much. Andrej, you want to add something?
No, maybe I also wasn't sure that I completely understand the question from the beginning. So simplicity, and then from the end user perspective. So not to repeat my colleague, but just to indicate, for example, though it's not a regulatory work per se, what we have tried to do is to facilitate some kind of communication on nanomaterials also through the European Union Observatory for Nanomaterials, in which we have partly tried to do what Alex was explaining about trying to communicate on the materials and types and uses, but through the different work of the observatory also try to provide some context, try to illustrate why are they being used in the first place, where the benefits might come from, or how would those some uncertainties which had been identified, how they had tried to be addressed, or what are the different opinions still surrounding that. Those are, and then we try to commission at least 2 to 3 studies per year under the observatory that go into specific questions which some partly relate to this, trying to get a bit more transparency and information able to be communicated towards also the end user and the general public on the application of nanomaterials and nanotechnology.
Yeah, indeed. Excellent reference to the observatory. Yeah, I agree fully on that. I think we may have another question on the chat, Sean. I see that the number is increasing. So
yes, we have a specific. It's quite a very specific question. Okay. And it's directed towards Andrej, but I'm sure other people might have a viewpoint on it as well. Regarding revision of the EU definition of nanomaterials and associated guidance published this year by the JRC, for implementation of this revision, the case of polycrystalline is challenging for several manufacturers. I'm wondering if a guidance is in progress or planned to explain which type of information are required to demonstrate the crystallinity of the material.
I would not say that there is any further very specific action currently ongoing beyond the guidance that has been issued, and that is now we are maybe also taking feedback because we understood it was the first version. We are receiving feedback, or rather, our Joint Research Center is receiving feedback on its use, on its usefulness, and maybe also on the missing parts. So with that respect, if that information with regard to polycrystalline materials and how all the methods that are described there could be applied to these materials is to be included, I would have to say I cannot. Yeah, I'll certainly note. We'll also come back to our colleagues that this might be an open question. How much is it covered, and whether for me to argue that there is a simple way of dealing with it. I would rather not try to dwell into those details now. I have a perception in my head, but I'm a reborn administrator. I'm a physicist, but I'm a reborn bureaucrat. So maybe I have missed on the finer points of application. I do believe that it's addressed this issue there.
Yeah, I think it's a question to be follow up with the JRC, who are working on this. But interesting that if there is a need that needs to be addressed, that then yes, we have to put it forward to the JRC.
And we'll do it in the revised guidance. Certainly, then we would include specific references chapter or whatever.
Thank you, Andrea. Any other questions, Sean? I don't know if I see anything more in the chat or.
No, I think that's it in terms of direct questions.
Great. Okay, so I think then we can move on to the next session. And I thank you very much to the panelists for your time and excellent answers. Thank you so much, and I'll hand it over to Sean.
Thank you to everybody for that. As Blanca sort of thanked all the speakers, I will also now just ask the new panel members to come in. And so we're moving now to look at global leadership in next generation materials innovation, supporting the advanced and nanomaterials industry in the US and the EU. And for this panel, we're going to be joined by Branden Brough, who's Director of the National Nanotechnology Coordination Office in the US, Amaya Igartua, who's the Coordinator of European Actions in Materials at TEKNIKER, and also a member of the core team for the Advanced Materials Initiative 2030, and Ana Cabrezio Martin, who's the Product Manager at the Spanish company NANOGAP. And I just want to say very special thanks already to Ana, who's joined us at very short notice when our previous panel member, Selena, unfortunately had to withdraw. So obviously, nanotechnology, really broad topic. And obviously, we've been working in nanomaterials now for several decades. Nanomaterials, of course, are found in many products. But often it's still simple nanomaterials, such as carbon black, that are really being used in the greatest quantities. What I really would like to ask the panel is, how can we support the more advanced nanomaterials to actually get into the market sort of in significant quantities? And maybe I'll come to Branden first, if that's okay.
Sure. Thanks, Sean. Thanks everyone for having me. Good morning, good afternoon, and good night. I think that you're exactly right. I think that there's a lot of really great success stories in terms of getting nanomaterials into products, but one of the big challenges, and I feel a bit sheepish telling this audience this, but nanomaterials are very small. And if you want a big impact, the science of scale up is really a challenge. And I think that there's a lot of efforts in the US as well as around the world in terms of discovering certain materials, discovering certain phenomena, characterizing them. I think that we've done a lot of great work in materials discovery, but the science of scale up, I think, is undervalued. And I think that it's also in this proverbial valley of death where it's unclear whose responsibility it is. Is that something that government should be doing? Is that something that industry should be doing? It's something that it comes to mind. I was talking to some folks at Huntsman recently. I don't know if you guys saw the press release, but they are looking to scale up manufacture of carbon nanotubes. And I was talking to one of the vice presidents there, and they said, we can do all the lab experiments we want, we can do all the theory, but in the end, we have to build something and start turning some knobs and actually doing it and figuring out how we can create these things at a size and a volume where it's going to be impactful. And the science is not trivial, it's not understood. And so I think that's really one of the things that I've been working on here in the US is making sure that some of the basic researchers are being informed by some of the folks who are more on the manufacturing side and vice versa, and doing a little bit of matchmaking there. I think that the Manufacturing USA centers are a great model, but it's not the only model. These are kind of collaborative, shared infrastructure for the sake of scale up. And I think that's a great program that frankly we need a little bit more of, and we're trying to engage with them more. But I'll shut up now and let others talk.
Thank you, Branden. And maybe turning to Ana and sort of saying, obviously working in a company that's looking to produce advanced materials and to scale it up and to get those to the market. Are you recognizing very much what sort of some of the comments that Branden said about scale up is the challenge still?
You are muted, Ana.
Hi, Sean. Hi, everyone. Thanks for this meeting. It's true that I am working in nanomaterial in the research of new nanomaterials and new application, and according to my experience, it's true that the scale up is challenging because we observe that this nanomaterial has important or great properties, new properties, but it's true that change a lot when you are in the lab, and when you change the scale levels, you obtain different products, and it's difficult to adjust the condition, adjust the parameters to get the same product that you are looking for at the beginning. But it's true that NANOGAP is working on this for 20 years, and I think at the end is possible, and now the techniques, the characterization techniques are progress at very good speed, and it's possible to get the new nanomaterials and characterize these materials in a proper way to provide this for the end user and to get new products.
Okay, and Amaya, obviously from the AMI 2030 perspective, you're building very much on the sort of previous experience of the nano community and broadening it out to a wider class of materials. Are you recognizing a very similar challenge that's going to be there in terms of getting these new materials to market, looking at the issues around scale up?
Yes. When you start with new nanomaterial, the scale up is challenging. Always is challenging. I think that yes.
Yeah, concerning the experience in 2030, what we are looking for is to accelerate the design, development, and uptake of safe and sustainable by design materials towards circular economy. In that sense, to select also frontier materials that includes nanomaterials to, let's say, to analyze the safe and sustainable by design concept in terms of using models for predicting nano safety properties of nanomaterials, and also to take into account the overall life cycle of the advanced materials. And we think that nanomaterials have a lot of potential, and also other advanced materials that have to be in competition in order to reach the best application from the best material. But of course, nanomaterial has a potential, as we see, because of the surface that it's the ratio between the volume and the surface that the nanomaterials have could have great opportunities for designing of light materials, and this will in fact reduce the energy consumption during use of this material, affecting the environmental impact, that's reducing the weight, reduce the energy consumption in mobility. And then this is just one example in which nanomaterials can be introduced. There are other many nanomaterials that application, but due to the properties that has been highlighted in terms of electrical properties or other, the important thing is to facilitate the scale up using characterization, but also modeling tools in order to let's say understand better the properties. And also there is a huge potential or combination of materials, and if this characterization and modeling properties of the nanomaterials can be put together with manufacturing technologies into during a scale up, it will be possible to facilitate the scale up of nanomaterials and to put together with the different materials innovation marketing which these materials can be introduced. And if the needs of the nanomaterials can be fulfilled for many different innovation market, it will be possible to, let's say, to reach a volume in which is cost efficient to be able to be scale up. Then if during this scale up of this, it is possible to mitigate the toxicity. I introduced in the chat one paper that we were publishing during NanoReg project in terms of mitigating the toxicity of the nanoparticles, also combining with natural material organic. It was during the testing phase that the natural organic material that was used for the test was really eliminated any toxicity. Then this type of finding that was found during the evaluation of toxicity, it could be used as well in the formulation of nanomaterials in order to have a reduced environmental impact, and also during manufacturing, but also during the use phase and end of life. Then I think that the potential is to put all the stakeholders together in order to understand the full potential in those applications in which could have a very good environmental impact by introducing the nanomaterials.
Okay, perfect. Thank you, Amaya. If any of the audience has any questions, then please do put them into the chat. If you've got any complex questions that you want to ask, just indicate that in the chat and we can certainly give you the floor and let you ask the questions. But as we don't seem to have any questions from the audience yet, and I'll come back onto the one that was sort of asked previously, but just as a little follow-up to what people were saying, one of the challenges we've certainly seen when we talk to some of our members is there does seem to still be some resistance in the sort of potential nanomaterial use community. There still seems to be some resistance for them to specify nanomaterials for use in their products. So how can we encourage some of the potential end users in markets such as aerospace or automotive or energy to actually look at nanomaterials? And is it a case of, is it a price issue? Is it a wariness of using nanomaterials because potential hazards or handling challenges? But I'm just wondering, first of all, is that something you've kind of seen in your business, Ana? And how, if you've seen this sort of issue of end users potentially being skeptical about using nanomaterials, how have you addressed that as a company?
Okay, it's true that we observe some difficulties to put the nanomaterials in the final end user. It's true that NANOGAP is so great, so grateful with some project, European project, in which we have the opportunity to join or to participate with other partners, including end user. And in some way was a great way to show the really properties or the really potential of these materials in terms of safety, in terms of properties in itself. And for us was great to know our materials, our properties, and to convince at the final end user that they can use, because this material or offer these potential properties that can reduce the cost of the market and offer new materials or new products to be different in the market, you know. And this was a good way. I don't know, perhaps at the end you have to convince that your product is the best, and I think the best way is to show your properties with real samples, you know, and be sure that you are able to increase the capacity or to supply the enough materials, enough quantities to cover their market.
Perfect, thank you. That's very, very informative. And Branden, from a sort of government perspective, what role can policymakers play in this, in sort of encouraging new materials to sort of enter the market? Because obviously having new materials is great, but actually getting them through and actually having them specified and used is vital for the industry.
Yeah, you know, I think it's interesting for those of us who have been around for a little while. We've seen kind of this ebb and flow in terms of what the public thinks about nano. I remember, 15, 20 years ago, you slap nano on anything and people get excited about it. We remember the Apple called, branded entire line of products, they're nano. And we see this all the time. I think that we're seeing kind of the pendulum swing in the opposite direction. Related to the question, how do we make this easy? I'll quote my high school physics teacher. We walked into class the very first day and he said, "There's nothing I can do to make physics easy. Physics is just hard. I'm just going to make it clear." And I think that's the approach that we have to take here, is that there's not an easy way to explain to lay people what a nanomaterial is and why it's exciting. But I do think we owe it to them to make it as clear as possible, to do our homework. Amaya mentioned, the European safe and sustainable by design. I think that is something that in the US has been rather innovative for an emerging technology to have the scientific discovery process go hand in hand with the safety and environmental analysis of these emerging technologies. And I think we need to do a better job of telling the public that unlike so many technologies in the history of science, we are not moving technology first, safety second, that this is something that is going in parallel, and to spend as much text on why we're excited about this material, but also why we're confident we know how to use it in a safe way. It's a constant communication challenge. There is going to be no mission accomplished banner at any time. It's a constant reminder that we have to bring the public into these conversations at all points, and that their concerns are valid. Whether they are scientifically valid or not can be debated, but we have to take it seriously and bring people into the fold. It cannot simply be government and PhDs in some dark, mysterious room.
Okay, thank you for that, Branden. And Amaya, the whole AMI 2030 initiative has been excellent at sort of convincing the European Commission that the research is obviously important. How will the AMI 2030 initiative now do the next step and convincing the manufacturers that they want to actually start using advanced materials as new materials or replacement materials in their products?
Yes, I think that nanomaterials have, in some way, what we have been doing, and we are in the process now, is AMI 2030, that is the materials initiative in which the different platforms, materials platform, materials for energy initiative, sustainable chemical manufacturing, put together the effort to create AMI 2030. But now we are in a process also to commit and to integrate and to involve the 2D materials and graphene plastic initiative into advanced materials, innovative materials, in order to, let's say, to create a co-programming partnership all together in order to influence the future European Commission programs in materials, in bringing two concepts that are the development of materials, taking into account not only the materials per se, but also the transformation, scale up, the use phase and end of life, in order to consider from the design of the materials also the circular economy, what will happen with the materials and the end of the life, putting together with digital technologies in order to scale up the materials, to consider production, processing, characterization and modeling activity, and also the European policy regulatory framework in order to consider this and convert these advanced materials in safe and sustainable by design materials, taking into account the needs of different innovation markets, and consider as a whole in order to have the enough volume in the different innovation markets in order to facilitate the scale up of the materials from technologies of production and also volume, and construct together with the nanomaterials work what could be the future materials in Europe and outside Europe, and this is the wish, and how to do it. It is, of course, it is very important also the credibility of the, and also the citizens. They should understand that the nano is a potential challenge that we have, And we should exploit all this potential in order to develop the next generation of advanced materials in the future. And not only consider nanomaterials, but also those materials that has to be resilient, should substitute critical raw material, and nanomaterials, since they can extract this so small, can help to minimization of components in the future. And because of the properties as well, it could have a role for substitute critical raw materials, but should be also resilient, resource efficient, to have a contribution to reduce CO2 emission, could be frontier materials. And also we intend to involve renewable materials, and of course to think on the development of new materials, the circularity. And this is more or less in order to strengthen the competitiveness of industry, but also taking into account Green Deal.
Perfect, thank you. Obviously, one of the challenges that we're finding, or that many people are sort of certainly finding, is we're dealing with a very complex subject, and we're dealing with something that probably needs new skills, and get those skills out into the workforce. Just sort of initially, sort of from Branden's perspective, what sort of thinking is there from a policymaker's perspective in how we can upskill the workforce, challenge the sort of manufacturing is a dirty profession, low skills, and actually bring some of those skills that are needed to try and ensure that we can make best use of the advanced materials that are coming through?
Yeah, I think that's something that in the US, there's a lot of hand-wringing around workforce. And I think something that I should say first and foremost is that when we're talking about nanomaterials, advanced materials, basically cutting-edge science, I think that the knee-jerk reaction is that we need more PhDs. And that's not to say, we certainly do need more PhDs, but I think that the real gap, at least in the US, is at the technician level, and the folks who are on the floor making these materials, and then taking kind of that logical step one further. We have the Chips and Science Act in the United States, which is intended to bring a lot more manufacturing to the US around semiconductors. I was talking to somebody and they said, what we really need in the next 5 years is people who can lay concrete to build these factories. And so when we think about workforce, I want to start off by simply saying that it's not simply the PhDs, it's the technicians, but it's also everyone around these emerging and growing industries that we are going to need all hands on deck. In terms of how we do it, I think that there's any number of different programs out there that frankly are not as well utilized as they could be. I think in DC, people get very excited about creating new programs, and it's less sexy to utilize the ones that we have. And I think that greater effectiveness of the ones that we have is important as well. I think that there are parts of our population that are given opportunities in STEM, science, technology, engineering, and math. And then there's parts of our population that I think do not have the same opportunities. And I think that's one way to very quickly ensure that we can increase our workforce is by reaching into those communities that have been underutilized in the past. I'll probably just stop there and let others talk. I can talk workforce all the time, but I'll let others get a word in.
Okay. And Amaya, from a European perspective, is it very similar that AIMI 2030 is identified that there is a skills gap and that will need to at some point be addressed?
Yes, we are addressing what the skill gaps are in terms of building the concept safe and sustainable by design, methodologies and tools, also using advanced methods to predict toxicity, trying to avoid, when possible, animal testing, assuring the workers' protection during handling of nanomaterials, developing the nano advanced materials with a life cycle perspective, then the concept of how approach this, how to define the functional unit in order to consider not only the production of nanomaterials, but also the phase of use and end of life, and define the functional unit in that condition. And defining the use, it will be possible to quantify how the use of these nanomaterials could benefit also the environmental impact. For example, in the line material solution that I mentioned before, for example, when dealing with mobility of transport, and it is important to make an appropriate analysis of the LCA, but also to take into account the cost, reducing the cost, the environmental impact, and also the social life cycle improvement. Because if it is possible to substitute critical raw material, you imagine, then it's possible to also improve the social life cycle, environmental, because we can produce in Europe this material that can be used to, for example, to replace critical raw materials.
Okay, thank you. And Ana, from a company perspective, how easy are you finding it to recruit staff with the right skills when you need to?
Okay.
So Ana, I think you're muted, Ana.
Yes, please.
Sorry, Sam. Can you repeat? Sorry.
Yeah, from a company perspective, how easy does NANOGAP find it to recruit staff with the right skill sets?
I'm not sure. It's true that it's challenging, but it's possible. No, I think it's not the most challenging.
Okay. Right. So just turning to a couple of the questions that we have in the chat. And I think, Branden, I think you've already started addressing this one, but I'll turn to you first. How do you see the future of nanomaterials in energy storage applications?
Yeah, so as I put in the chat, the United States for the last year have had this national challenge that is meant to connect the basic science of nanotechnology and connect it to some of the most pressing societal and societal challenges, and that being climate change in this particular case. So we have this thing called Nano for Earth, which is connecting nanotech solutions with climate change. And we had this roundtable on batteries and energy storage, and I put a link to the summary of that discussion. I think it is, for those of you who are in the nano world, I think it's easy for all of us to understand how critical nanomaterials, nano coatings, membranes, lubricants, porous materials, all these things have tremendous potential. And I think in batteries, there are not very many advanced batteries that don't have carbon nanotubes in them right now. Now, it is not exactly the highest form of carbon nanotubes, but carbon nanotubes have helped lithium ion get off the ground. You're seeing a lot of really interesting new chemistries being explored in terms of batteries. chemistries that require new surface coatings and new membranes in order to operate properly. You're looking at lithium silicon batteries, where the silicon is nanotextured, and you're seeing some of those batteries being put into Mercedes cars at the moment. In terms of energy storage, you look at the hydrogen economy and what kinds of surface coatings, nano surface coatings are going to be required if we're going to be moving hydrogen around, if we're going to be able to control the flow of hydrogen and the storage of hydrogen. It's really quite exhaustive in terms of the different potentials. And it goes back to that first question about how we can scale some of these things, because nearly every solution I just rattled off can be demonstrated pretty easily in a laboratory. It's a lot more difficult to scale it up at a cost that's going to be competitive, because these disruptive technologies, as Landon was alluding to, it's more than just putting out a better product. It's more than just putting out a better product at a better price. It has to be so outstanding that people are willing to completely overhaul their manufacturing facilities, their supply chain agreements, their ability to discuss new technologies with the consumer. There's a really high activation energy sometimes. And I think that these are all things that we're trying to talk about, not just getting excited about the technology, which I think is very easy to do, but there are some very practical concerns that we have to map out and be intentional about as we move forward.
Okay. And Amaya, from the AMI 2030, obviously energy is one of the areas that you would or the initiative was focusing on. What do you think? And I know obviously this is a very open-ended question, so maybe just a very relatively short response. What are the interesting things that are emerging in terms of energy storage that you think will be coming out over the next sort of 5, 10, 15-year period?
Yeah, for energy storage, I think that we have not only batteries, but also hydrogen economy that could reduce the need of critical raw materials, and will give also challenge for nanomaterials and to be developed. And I think that we should not consider only one vector of energy for storage, but also other vectors that can play a role. And I think that is very important to consider to minimize the need of critical raw materials. And I think that nanomaterials could play a key role in energy storage because of the functionality that can be provided in a minimal space, and also it's necessary to highlight and to test the durability of the materials and also the traceability. It has been highlighted also for one of the attendants on the evening in the chat that the traceability of materials is important. And in this way, one of the priorities that from AMI 2030 and the innovative materials for EU partnership that we are building is to facilitate the advanced materials identification and traceability, connecting with digital material and products passport. I think that it is, of course, needed also regulation in that in order to address this issue, but because it's not good that traceability will be defined by each one, but to have a common harmonization of how digitalization of materials should be addressed. But in this digitalization, it could be included the content of nanomaterials, also to have information of how it needs to be handled, at the different levels along the value chain, and also to facilitate the recycling and the conversion of to new materials, because it is very important that the materials, not only nanomaterials, but all of them, are designing for circular economy. And in that way, it will be possible to increase the durability and reuse and also recycle at the end of the life. And then this traceability of the materials and nanomaterials will be needed.
Okay, perfect. Thank you. We've got a very specific question here, and I'm not sure we're actually going to necessarily do the full question justice, because I'm not sure we've necessarily got the right people on the panel. But I can maybe make something out from what Binion asked around how do we view the potential of biological magnetic nanomaterials? And the exact question is, how does the NIA view the potential of biological magnetic nanomaterials, especially those derived from magnetic bacteria or microorganisms in current platforms? And they're seeking insights on potential applications and strategies for connecting with end users, which I think we starts getting very specific. But maybe the question should really be, how do we see nanomaterials moving forward and combining, for example, with biomaterials to give us new potential products in areas that are going to be challenging in terms of regulation, user acceptance, and as well as the technological challenges, such as biomedicine. And maybe first to Branden, and then maybe Amaya as well afterwards. But Branden first, maybe.
Sure. Yeah. I think from a policy standpoint, I think if it's a bio nanomaterial or a inorganic nanomaterial, I don't think the policy necessarily has to change. I think this goes back to that very first question for the first panel in terms of how we define the field. I think that in my world, where we're talking about nanotechnology, biomaterials are absolutely part of the conversation. I think that in the end, I define kind of nanomaterials or nanotechnology as kind of around the emerging properties and less so about the size. I think that we can be a little bit narrow-minded when we stick to this 1 to 100 nanometers. A nanometer means nothing to Mother Nature. And so I think that things like biomaterials are absolutely qualify. They behave differently. They behave in exciting ways because of their size. And to me, that falls under the umbrella. And so I think a lot of the discussion around regulation, around communication, around consumer adoption, around proactive safety and sustainability, all these things apply, in my view, to biomaterials. Now, I can't speak to how NIA feels about all of this, but that's kind of my 2 cents.
Okay, and Amaya, maybe a question from the AMI 2030 perspective. How do we bring together the right areas of research in terms of bio, materials, nano, that we're going to need to allow some of these innovations to come through to the market?
Those innovation of the materials and magnetic properties can be very useful also for separation properties of nanomaterials for recycling. It can be used also for bioremediation. Then I think that the possibilities to combine recyclability with biomaterials or nanomaterials could be very challenging for the future, and having the community together and addressing the real needs from the industry and also from environment, it will be possible to exploit the potential of nanomaterials and advanced materials in the future.
Perfect, thank you. Starting to come to sort of some form of conclusion around the panel. My final sort of question for the panel members is going to be, what would you say are the main barriers to bringing new nanomaterials, new innovations in this area to the market? And whether these barriers are technological or policy, it'd be very interesting to see what you think your number one barrier is and how that can actually be addressed. And maybe if I turn to Ana first. I think you're on mute again, Ana. Sorry.
Sorry again. I think that nowadays the nanomaterial are more common, of everybody speak more with about the nanomaterials. I don't know, due to advertisement or something like that, but at the end, the most important of the nanomaterial or new material are the properties. And it's true that every nanomaterial has new exciting properties, and if you can find this property and you can look for new platforms, I don't know, this is a great platform, or other platform as symposium or a conference to speak about your properties, you can get to show the nanomaterials and put in the market. And I think it's a good way to work or to speak about this material as normally, as more common or a great product.
Perfect, thank you. And Amaya, what will Amy 2030 be doing to help overcome some of the barriers that we've seen to bringing new materials to market?
Let's say first to try to address all the stakeholders together in order to think the design phase of the material, or what are the main challenges, to be focused to find some application that may have a big challenge, and bring together manufacturers, developer on the materials, scale up, together with manufacturing, also regulators of nanomaterials, and testing, modeling activities, put all together in order to collaborate together, in order to have the product in the market, and to also to communicate to all the stakeholders what you are doing from the design phase of the material, and also track during the use of this material, in order to be, especially at the beginning, at the design phase of the materials, because in that way everybody will be aware that you are introducing a new product in the market, and then all the steps that you are doing, everything will be considered from the point of view of safety of the workers, on the users, on the end of life, and each point with a concrete case that is there, it will be analyzed from all the point of view. And in that way, we think that it will be possible to develop and exploit in a better way, more successful way, the new generation of nanomaterials in the market.
Okay, perfect. And Branden, I suppose, last word on this to you. From a policymaker perspective, what do you think the main barriers are, and what, from a policy terms, can be done to help overcome some of those barriers to bringing new materials through to the market?
Yeah, I think we've touched on a lot of them. And, as was just said, I think getting all the right people in the room, I think that in the beginning, nanoscience was very much an academic exercise. And I think that a lot of the center of mass was around kind of the development of new phenomena, new material, so to speak, and was not informed as much as it could be by people further up the TRL level, whether it's about manufacturing, whether it's the economics, whether it's the regulation. I think, as Amaya said, having all those folks in the same room because developing new technologies is hard. I don't have to tell this group, and you can stumble at any point. And I think that being proactive and getting those people at the table early on, and imagining things far beyond just getting published in Science and Nature and calling it a day. We had a comment in the chat about nanocellulose. Nanocellulose is a tremendously high potential material. There's a lot of interest in it. And I was talking to folks, and they were saying that one of the big hangups is building codes, that they want to put nanocellulose in concrete. But we have to modernize our building codes to allow for that. Until then, there's no market. And with no market, there's no future. So really getting in front of all these little potential stumbling blocks, and not just making this an academic exercise in creating some new material that's 100 times stronger than steel. That's all well and good, but I think we need to move past that and make sure that we can get these things into products in a safe and kind of intentional way.
Okay, perfect. Well, I'd just like to sort of thank all of the panel. There are a few more questions in the chat that we unfortunately haven't really had time to come around and address, but we will try and get answers out to people. Thank you ever so much to Branden from the NNCO in the US, to Amaya from TEKNIKER in the AMI 2030 initiative, and to Ana from NANOGAP. And I'll just like to sort of see if Landon has any further words just before we start bringing the meeting to a close.
Well, if I could operate my video camera, that would be a start. No, I just want to first of all, thank all of our panel members today for joining. I thought they all brought unique and differentiated insights to the conversation. As I mentioned at the top of the conversation, the thing that we're focused now is really about building the community, engaging the community, and becoming having much more bi-directional conversation with the various regulators and key stakeholders, which we haven't previously done because we've been focused primarily on regulatory. And so I think it's an exciting time for the NIA with a reinvigorated vision. Again, I would highly encourage everybody that's on this call today to, at minimum, join the newsletter so you can keep tabs on what's going on at the NIA and understand some of the policy actions that are happening both in the United States and the EU, and seriously consider becoming a member. The value that the NIA brings today, I think, is substantial, but we really are looking to substantially increase the value that members will receive in the future. And with that, I'll hand it back to Sean. But thank you very much, everybody, for taking a little bit of time out of your day.
Thanks ever so much, Landon. And so finally, just to sort of wrap up, just say thank you ever so much, following on from Landon, to all of the people who have spoken today. It's been very useful. Thanks to all the NIA members who continue to support us. And finally, thanks to everyone in the audience for joining us here today. As Landon says, the NIA would like to become or to ensure that we remain the definitive global voice of the nanotechnology industry. And obviously to do that, we need you. We need people who can come tell us what the latest things are, what their needs are, help us talk to the policymakers, help us ensure that we can continue to grow the sector. So as Landon's just said, stay plugged in, join the newsletter, join us as a member, and certainly help spread the word. Thank you ever so much, everyone, for attending. For NIA members, we'll just take a short